My name is FARAH binti BASIR. My matric number is S62573. And these are the problem for array. This is the algorithm for problem 1. First, we start the program, and second, we use stack to read the length of the stack. The third, we insert the sequence bracket, and fourth, after we insert the sequence bracket, we check if the sequence bracket is correct. If the sequence bracket is incorrect, then the program will terminate. And fifth, we display the result, and lastly, stop the program.
Hello, I am AISHA ARDINA binti Muhammad ZAKHUWAN with matric number S63669, and I will be solving the problem 2, which is stack. And this is the question for problem 2. At the start of the program, we define the array, which encapsulates the property of integer n after getting the size of the array. Then we acquire the users to input the integers according to its size. For example, if the size is 3, then the integer that will be input is 3. Then we define integer A and integer B, where integer A starts with the start of the element, and integer B starts with the end of the element. While A is bigger and equals to B, the loop will continue. The values of the elements are compared in the loop, and then the output of the comparison will be printed and the program will be terminated.
Assalamualaikum and hi, my name is AINA BALQI. My matric number is S62674. Today I'm going to present to you problem 3, which is Q. This is the question for problem. Now let's take a look at the algorithm for the problem 3. First, start the program and ask the user to input the total number of disks in the first line. And in the second line, input integers in which the integers denote the size of disks that are given on the which day. And the list of integers will be input by user, and it will loop until it reaches the number of total disks. And next, iterates through the disks in the tower. For each disk, it checks if there are any larger disks later in the tower, and if not, it adds the current disk to the list. Next, if no larger disks are found, it sorts the list in descending order and prints out the size of the disk in the list. And then clears the list to prepare for the next iteration. And next, repeat the process until all disks have been checked. And lastly, prints out the output. Next, as you can see, this is the source code for the Q problem. So, when the code is executed, on the first day, the disk of size 4 is given, but the disk cannot be put on the bottom of the tower as the disk of size is still remaining. On the second day, the disk of size 5 will be given. So now disk of size 5 and 4 can be placed on the tower. Next, on the third and fourth day, disks cannot be placed on the tower as the disk of 3 needs to be given yet. Therefore, these lines are empty. On the fifth day, all the disks of size 3, 2, and 1 can be placed on the top of the tower. That's all from me. Thank you.
Hi and Assalamualaikum. I am AINUL S61496 will be presenting about problem number 4, that is binary tree. This is the question for the binary tree. This is an algorithm to solve the problem number 4. The first step is to create a stack. Each color needs one stack that was initialized as an empty stack. Then start the depth first search from the root that has vertex 1. If stack at call is not empty, the vertex that is the nearest ancestor of V and shares the same color as V is found at the top of the stack. The answer to V will be -1 if the stack is empty and the necessary vertex does not exist. Next, vertex V is placed in the stack at call. Run a depth first search from all vertex ones. Take the vertex off the stack at call, and the color data will be kept on a single path from the root to V during depth first search at the vertex. The vertex number on the root from the root to V that has color is contained in stack at call. The vertices are pushed onto the stack in the order in which they were visited by the color. Now, let's see the runtime of the code.